Hey, what's going on, guys? Let's do this problem right here. This question is asking what is the intervals of convergence for e power x square, and that is given in power series format. Now let's see how we can find it. To find that one out, what we do, we take the ratio test. So ratio test is limit n approaches infinity, and we have to take absolute value of an plus 1 over an, right? So in order to be converged, this ratio should be less than 1. Now let's figure out the ratio first and see what we get. So first of all, we have limit n approaches infinity and an plus 1. It's going to be, so here what we do is wherever we have n, we just add 1 to that. So the numerator is going to be x power 2n plus 1. So here 2 times n plus 1. Right, so this is going to be 2n plus 2. Now in the denominator we are going to have n plus 1 factorial, right? So this is the one we are going to have, and then we have to divide this one by the original function, that is this one. But dividing by original function is same as multiplying by its reciprocal, so we can multiply this one by n factorial over x power 2n, right? So here we can expand this one. So this is going to be limit n approaches infinity, and this is going to be x power 2n plus 2, right? And in the denominator we are going to have n plus 1 factorial times n factorial over x power 2n. And you can see that this term is going to cancel out, x power 2n and x power 2n. So we are only having x power 2 right here, because this term is same as x power 2n times x power 2, so that's what gives us x power 2n plus 2. And if we cancel this one, x power 2 will remain, and these two things is there. And this one factorial, you can see that factorial goes like this. If it's n plus 1 factorial, it will goes like n plus 1, then n, so it decreases one value every time. It decreases one value, n minus 1, and it goes so on, right? And finish at 2, like 3 2 1, so it end like that. So for n, it's going to be starting from here, n minus 1, then so on, and same values. So you can see that n plus 1, the only difference is this is we are going to have n plus 1 remaining, and the other things are going to be same. So we can cancel this one and this one. So we are going to have n plus 1 in the denominator. So x square in the numerator, and n plus 1 in the denominator. Now let's see what that will do. So let's write this one out first. Limit n approaches infinity, x square over n plus 1. Now we can take this x square to outside because we are only dealing with the n right here. So we can take this one outside. So if I take this one outside, let's continue this one right here. So if I take x square outside, this is going to be absolute value x square, limit n approaches infinity, and then we are going to have 1 over n plus 1, right? So from this one you can see that this is going to be 0, because if you apply infinity for this n value, this is going to be 1 over infinity, and that's going to give us 0. So this is same as x square times 0. And in order for this ratio to converge, this ratio should be, in order to converge, this one should be less than 1, right? And if you can notice, if no matter what number you plug, but before so no matter what number you plug, this is going to give us less than 0. You can try any number, because if you multiply any number by 0, that's going to give us 0. So that's going to be less than 1. So the intervals of convergence is going to be negative infinity to positive infinity, because you can apply any numbers to get 0. So that's going to be our interval of convergence, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.